Okay, my outstanding friends, I have been talking about light and the particles that make up light. They're made of particles, and they have a field surrounding them. So the field has to push through, and it makes a wave around the field. But the particle is in the center of the field. So it's particle-wave duality, no question. And we show that here. Now, this goes back to 2012. I'm going to show you something, how this whole thing started. And this is from FERMILAB in 2013, same particles. Now let me show you how this started. Okay, so don't forget now, Rod's got a new Samsung phone right around 2012, and he's putting up all these pictures of light, and people are saying, big deal, what's this? Well, as soon as I saw it, I knew what it was. It's light accelerating. That's light not accelerating. That's light in the acceleration phase. That light right there is splitting from the black and white particles dividing. And there's the black and white particles. I'm going to show these in very close detail. And these are the Higgs fields coming through the Venturi, exploding. And this is some kind of exotic particle, and I can show you how this manifested itself. And that is not standard. That's not standard by any means. These are standard Higgs. I have got so much on this. And this is blue spinning, and this particular phone can take all those pictures at one shot. I think I mentioned that. Instantaneously with zero flutter speed and instantaneous 20 or more. I think 20 pictures, done. Okay, my friends, this is all you need right here to understand the whole shooting match. Now, this is Professor Shankar at Yale. And you could take all these classes online for free, which I did. I looked at electrostatic, electrofields, quantum mechanics, and everything. He goes through the whole thing, all of this stuff. And he's not a bad guy. He's an honest guy, to be honest with you. I liked him, but nothing made any sense. And she's nice, but she won't communicate with me, Sabine. And I've been posting on her Facebook. You see, Professor Shankar, but let me show you the first thing he says. Okay, so when I saw what Rod had, I started going everywhere for quantum physics. And I started with Yale because, you know, I want to see what they say. Because everybody says talk to somebody at Yale like they're the big shots. Well, he's a nice guy, but he admits right off the bat they don't have any idea what they're doing. Listen to this.
It's a very exciting day for me because today we're going to start quantum mechanics, and that's all we'll do till the end of the term. Now, I got bad news and good news. The bad news is that it's a subject that's kind of hard to follow intuitively, and the good news is that nobody can follow it intuitively. Richard Feynman, one of the big figures in physics, used to say no one understands quantum mechanics. So in some sense the pressure is off for you guys because I don't get it and you don't get it and Feynman doesn't get it. The point is, here's my goal. Right now, I am the only one who doesn't understand quantum mechanics. In about 7 days, all of you will be unable to understand quantum mechanics. Then you can go back and spread your ignorance everywhere else. That's the only legacy a teacher can want. So, all right. So
anyway,
that's the spirit in which we are doing.
So he's honest. What can I say about that? Yeah, here it is right here. The Samsung improved the camera's software over that of the predecessor, included zero shutter lag and a burst shot mode that allows capturing of 20 full resolution photos per row in quick succession. Now, do you have to put it into that mode? Burst shot mode. And then there's all kinds of things I also do. Another feature, best shot, allows selecting the best photo out of 8 frames captured in quick succession. Rod did all that stuff, and he used this phone, and it just happened. And then when I saw it, I freaked out because it proved everything I was saying for 50 years. All right, let's talk a little more about the camera. This is, again, this S3, Galaxy Samsung S3. Now, it has an 8 megapixel camera. You know, you can take pictures, 8 megapixels. That's quite a good number of pixels. Now, The crazy thing is, though, and again, I didn't talk much with Rod, but what he told me was he was using the selfie side, which, if I'm right, they're saying the front-facing camera can record a lot, but it has a 1.9 megapixel front-facing camera, so I believe that's the selfie side. You'd think that wouldn't be as perfect. However, I don't know, because the display is absolutely fabulous. And we had another guy, Fabien Boulet, did some fabulous work, but his phone was more blocky. Let me show you. Okay, this is why I got excited. These are the fields coming through the air, literally through the air, in a dark room, and the pulsed red laser is pushing all the other particles out of the way. That's why these are glowing. It's now accelerating, as you can easily see, and it's exploding at the Venturi. A Venturi is a known accelerator of water. And light is nothing but basically a liquid. It literally is. I'll show you. And the white part can separate from the black part. And you say, what, white and black? There they are right there. These are Higgs fields. And this is a exotic particle nobody else ever would know about except Rod and I. That is blue spinning forward and slowing down. Light speeds up, light slows down. A lot of things have to be re-examined. Okay, so Rod's got his Samsung, same one right here, Galaxy S3, and he's got this construction laser. And he's shining light through his Venturi he made, which he thought it was just going to have him do the regular double slit experiment, but it didn't. He created a Venturi, and the Venturi is, I'll show you what the restriction is, but he ended up seeing these same particles as FERMILAB. Now, he saw them coming out of his phone like the 2012 sometime, early into 2013, whatever. But when I saw this, Don Lincoln posted about these are the two smallest particles they can find. And there's some subatomic, and he just says exactly what we found is that the fixed particle, the black ball, has a fuzzy edge around it, which it does. We found the same thing. And the point-like particle, which is the white one, is a mathematical extraction. I don't know, it's got to have something, but it doesn't seem to have any weight whatsoever. It says even zero-sized particles, which that seems to be. I have to agree in this particular, but it has to have some, there's energy there. Let me just put it that way. I don't know how much it weighs, but it doesn't appear much. It says even the zero-sized particles have an extended field effect due to the field surrounding them. Surrounding what? That's the kid. That kills me. But they got a hell of a lot of energy. I can guarantee you that. Don't forget, fuzzy edge around the black one. The point-like particles can get big and small, and they don't have any weight. And those are the particles, literally, that are electricity. The white ones are electricity. If you push electricity into a battery, the battery will not gain any weight. Won't gain any weight. If your car weighs 4,000 pounds, uncharged, you can't move it. Nothing. Fill it all up with electricity. It still weighs 4,000 pounds. It didn't gain even an ounce. I'm telling you, they've done the test. It doesn't gain weight. So what happens? Where did that energy come from? It comes from those white zero-sized particles. And we were able to separate the white from the black. That's the key to generating electricity, is just get the white away from the black. That's all electricity is. All right, this is why I was so excited. I saw Don Lincoln's article. I saw the black particle with the glowing edge. I saw this one here. He says it can get big and small and it has no weight. We found exactly the same thing. The white one here is this. Now, it can be white, green, blue, which is the lasers we used, and the glowy edge will be the same color as the laser. Now, and these are the white particles. They can get big, they can get small, they have no weight whatsoever, none, zero. And as they go through the air, they bash into the particles in front of them, and they get glowy, and that's why this is getting bigger and bigger, and then it'll flip, and the discharge one will come in front. That's the muon wobble. And they're always up and down spin because they're polarized towards the Earth, because they are dipoles. And that's, everything's explained from dipole electron flood theory. These are only two particles that exist. That's it. Okay, my friends, in a minute we're going to go to my best new friend, Chat GPT. It answers honestly about everything. It's amazing. Now, I put in about light. Is photons in the quantum realm? Because people think quantum, oh, it's just scary. No, it isn't. Quantum just means under an atom. In other words, an atom is this big. If you had this big, that's in the quantum realm. If you had that big, it's in the quantum realm. If you had two of these, 6 of them, 20 of them, 50 of them, but when you get to a certain quantity, they become stable as a proton, which is the smallest atomic building block. And hydrogen is the smallest one. I claim it has, if Millikan's oil drop experiment is right, every electron here there would be 1,839 of these particles glued together, just like this, in a ball, which would be a proton. That's dipole electron flood theory, done. It's all over. That's as simple as that. There's no quarks and leptons and gluons. Well, there's gluons, and there's electrons, and then there's photons, and then there's protons. That's it. Electrons are one of these. It's a dipole. It has a positive and a negative. It's a magnet, basically, a little tiny magnet. And when they get together, two of them, like this, one side of that, it would be a magnet, okay? A plus and a black and white. It's just a magnet. That's what a bar magnet is. Now, if you took two of them back to back, which would be this, you have a photon. Now, what's the difference between an electron and a photon? One of them wants to be attached to something. It's going to be heat or electricity. It's not going to sit by itself. It wants to be attached to something. It's going to find something to glue onto. Usually, if they're floating free, they'll end up being static electricity on your body, or in the air if there's just an excess of these. They will accumulate together and create lightning. They want to get to Earth, which is ground, because Earth has all of these black particles, tons of them, and they always point this way, straight down to Earth. That's why you have an upspin and a downspin. This would be considered a downspin, because the particle is facing down and getting glowy going forward. See it getting glowy? That's this in just a shade thing. But you can see the black goes right with it. Now, what is that? That's the wave. That's the particle. The particle is in here, but it has a field surrounding it. So as the field goes through the air, all of these particles glow because they have fields too. Fields push against other fields. It's just the way it works. As this comes through, it's banging all those. You see them glowing here? You don't see them back here. It's already come through here. Now it's starting to accelerate, and then we're getting pushing field to field. That's when you get this effect. Now let me show you some things that'll blow your mind if you haven't seen them, which most people have if you've been here, but you may not have understood it. I get a lot of people, oh, I don't understand what you're talking about. Well, you might have to look at this 3 or 4 times. I don't know. I think I make it pretty simple. Is light in the quantum realm? Quantum, like I say, is underneath protons. Obviously it is. Yes, light is a photons. It's composed of particles called photons. Particles exhibit both wave and particle properties, and they've never been understand that. And there it is right there, I just showed it to you. There's the particle, there's the wave, and it's because there's a field surrounding the particle. It has to go through like a basketball, through the air. But there's only one little particle inside of it. All right, now, so quantum superposition, forget about that. Entanglement, all that means is the black and white particles are stuck together. And they don't understand this at all. They think once they're entangled, they'll never separate, or they'll be separated and go somewhere else, and the one that's way away will be affected by the one that's over here. No, they go apart, they come back together. Let me show you. The entanglement says that light can also exhibit quantum entanglement, where the state of one photon is linked to the state of another, no matter the distance between them. That's crazy. Changes to one will instantaneously affect the other, no matter the distance. Let me show you something. Okay, this is going to be a ramble. Hold on to your neutrons. Now, as I said, this gives you the whole batch. Light just beginning to accelerate, forcing these particles to push back, making fields. Now it's really under acceleration. Hits here, it divides, comes back together here. Now they're talking about entanglement. Do they think the particle, when it divides here, comes back to the same particle? I say no, obviously not. And what particle is it? Here it is right here. So when they come in here and they come in here and they smash into the Venturi, will the black find the same white? No. I very much doubt that. Watch this. Here's why I say that. All right, here's why I say it. These are the two entangled particles. You see them, the black ones and the white ones? Or this is an electron and that's an electron. However you want to look at it. But nobody ever knew the dark matter was attached to the white glowy matter. That's why nobody's ever known about the dark matter, because the dark matter goes to the center. It's in the center, surrounded by the white matter. So anytime they look at it, they say, "Oh, we can't see any dark matter." Well, it's inside. That's why. It clouds around it. That's the Dipole Electron Flood Theory. There is no one big, huge proton smashes into a particle zoo, and that's what they find now, because that's what they're using as these. We started with the smallest particles they could ever find, which is light. Light is in the quantum realm. It's the smallest particle. And then, because these ones can get bigger and smaller, but the black cannot, the design of the Venturi, which is this right here, dictates what is allowed to come through. These will shrink right down and squirt right through. The black can't get changed. It's a fixed particle, as Don Lincoln says. This is the extended fixed particle, never changes size. This one can get big and small and has no weight whatsoever. It's just, no question, these are the particles we found. Now, and like I say, I tried to work with Don and it didn't go well. And anyway, these are the particles. I don't see why we can't take a look at this white light, because that white is ripped away from the black, and that is what you need to create electricity. The white is electricity. I don't care what anybody says, that's what it is. All right, like I said, some people say, yeah, I can't understand what you're talking about. Let me try to just be very, very simple and plain. This laser, and it was a laser identical to this over in Australia, Rod Warren. He was beep, 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 and that's the pulses of the laser. Now, coming through the air, just right through the air. I don't think he had anything like even moisture in the air or anything. It was just through the air. The molecules of gases in the air have fields around them, just like every particle there is has a field around it. And this has to push it out of the way. Anytime you push something out of the way, I call it push to shove, you get glow. You see how much shoving you got going here? This is just the light beginning to accelerate. It's about right there. All right, this is about right there. Otherwise, you wouldn't even see it. Until it starts to accelerate, it's just one of the background little things that nobody ever sees. It's just light that isn't seen. I turn on this laser, you won't see it until it hits something. All right, I got it on right now. You can't see anything. Until it hits something, you don't see anything. I don't see anything until it hits something. What's going on? There's nothing there. Until I flick around and see it. All right, so here we go this way. You're not going to see anything up here or anything over here. The only reason you see this is because it's headed right into the Venturi. Now, if it didn't go into the Venturi, it would just not exist. You'd never see the light. It's there. You can tell because you're seeing these. You say, well, what are those? The same as this. You say, what is this? Well, it's the same as this. It's light being pulsed and starting to accelerate. And here it's on steroids acceleration. And then the key to this whole event is reverse electromotive force. What does that mean, Roger? Well, it means everything has a field. And once you start accelerating these fields, they stack up on each other and they just explode. The fields literally keep the black back, but the black slaps that white through there, and the black can't get through with it because the venturi is too tight. But the black keeps coming, and it just keeps squirting out of here, and I don't see any reason whatsoever we can't use that white. You see the energy here? All you have to do is look up luminosity. Look up the Large Hadron Collider luminosity experiments or something. Now they realize you don't have to do all this insane stuff with protons. Protons are nothing more than a ball of dipoles. And that's been totally proven now as far as I'm concerned. And so now we got acceleration of the light, and here it explodes, literally explodes, and we can see the photons. You're never going to see a photon, basically, except if you're at CERN or you're doing this, because the reverse happens to make it seem like a wall right here. That's when everything concusses, just like it was hitting a wall, and bouncing back in the spectrum of what it should bounce back from. Because it's going faster than it should, and everything's stacking up, and bow, right here, photons. And what are the photons? They're right here. Let's look at this red light in its acceleration phase until it explodes. And don't forget, where we're going to see it come is right about to here. We're going to see it starting here looking like something. And then you're going to see photons actually show up here, and then you're going to explode right there. So we won't even get down to here in the next pic. All right, I got the lights off so that we can see this better. Now, remember I said you're going to start over here coming this direction. I think you can see that, yes. Now, it starts, like I said, something. These are what you would call neutrinos, and they have a certain energetic value as they approach their target, because they will always be backing up, and they'll get stronger and stronger, but they don't turn into photons normally like these are. These are photons. They normally don't turn into something like that until they actually hit a wall. However, these things think they did hit a wall because of the reverse. You see this big white stripe coming back? That's going back against this. So between the two coming forward and coming back, you get a photon. Normally you're not going to see that until it actually hits the wall. And here is where the division happens. And this is where that feedback is. And these are reverse concussive waves. All right, but you see, that's a neutrino. Up here you're seeing neutrinos too, but they're not directly in the line of the venturi, so they're less energetic. This is where they really turn energetic and they explode. Now let's look at the reverse EMF. Don't forget, this is where the outside part of the white wave is. All right, before we get too deep, you got to understand how light works. It's a spinning, circular spinning particle. Now the particle sits on its own axis towards the Earth, up and down spin. But it also spins around this way. So it's spinning in a circle this way for up and down spin, and it's spinning around this way going forward. It's never going to tilt like this or like that. Although we did have that happen one time, and you'll never see it again. Nobody else has done it. CERN will never know it. We did it. Now this is literally a drill bit. The light is spinning this way, but it's polarized this way. That's what the up and down spin is. And then they talk about strange and all this crazy charm and everything. All you got is dipoles. And they're spinning around a circle as a photon heading forward. At the venturi, they separate. The white will go through and the black stays back. And that's what you're seeing is the white going through. And the reason you have all these separation lines is white hates each other. They will push each other into these discrete patterns that they see them. They call them, I forget what they call them even, to be honest with you, because it doesn't make any sense. These are repulsion patterns. They repulse each other, so they create these lines. And that's as the light spins in circles. Okay, we looked at this as it gains energy, and then it turns into a photon, and then this whole reverse white explosion happens as it enters the venturi. And here it is actually occurring. All right, here's the field that we originally saw, and it's really getting sucked forward. And here's the actual particle right here that I showed you, that black and white up and down particle. And here is where the explosion happens. Here's where we can see the actual photon. And why is it way out here instead of down here? Well, it's way out here because it thinks this is a wall. There's feeding back energy this way and energy coming this way. Between the two of them, at this specific point, they explode. And the black leaves the white. The white turns into a shower. The black surrounds it here. And then black reattaches here. If they're talking about entanglement, this black particle is not going to jump ahead and jump back to the white. Let me show you what does happen right here. It's pretty impressive. Now, the other thing is the reverse EMF. Remember these here? And something very intriguing here is that these are the leading edges. Every one of these is a leading edge of one of the same light particle. But this one, it happens to be right in the middle, and this one is creating all the energy. This is energy on steroids. White like that, it just doesn't happen. This is, to make this get white like that, you have to have a hell of a lot of energy. And where are you getting it from? Out, coming backwards. And what about this? You see that out there? This is like a boom, atomic, and it is, and I'm not kidding you, I'm not lying, this is a subatomic nuclear explosion. And the concussion waves are right there. Look at that, how far that is off. These are being excited into craziness because these are nothing more than photons too. And you can see the photon here becomes a full-fledged photon. And all these do too. And you never even would have saw them. They're not even there. They would be unseen. Now, what happens here? The black comes away from the white. And what happens here? The black comes back to the white. What happens here? You got nothing but raw electrons, which is there's no weight to them whatsoever. You put those in a battery, you drive all day long on that white stuff. All right, you should be able to grasp the concept by now. Again, these are FERMILAB particles, 2013. From 2013, and Rod found these. I can't remember the dates, but I think I know I had this up on the internet around 2015 saying this was Dipole Electron Flood Theory, and there was nothing but these two particles, and we could separate them. Normally they're glued together. They call that the strong nuclear force. This is in the nucleus. This is actually, hold on, let me turn this up. This is actually what a nucleus is. It's not like that. This is what a nucleus is. And every one of these together is held to each other by a strong nuclear force. And the strongest nuclear force is the bond between the white and the black. That's the strongest. That's the strong nuclear force. The weak nuclear force is like a chunk, a piece of this comes off. Those are called isotopes. Those are the weak nuclear force. This is the strong nuclear force, is the attachment of the gluons, which is the attachment of the black and the white, which is easy. Same thing FERMILAB found. Exact same, identical. I'm not going against FERMILAB. I'm just saying they don't know what they did. And when I presented this to Don Lincoln, I said, can we talk about it? He said, and I hate to get back into that. I mean, he just really assaulted me. He called me a tinfoil hat guy, an embarrassment to science, and he was pretty arrogant. And anyway, hopefully that will be water over the dam. We can talk about this and openly. You know, this is trillions of dollars, literally. I'm saying this is 10 years ago. And nothing's changed. They're still walking around in circles. I'm sorry, that's just a fact. And I'm blocked. I can't get through to anybody there or CERN. And I did go to the University of Geneva for particle physics, and I showed them all our stuff. And they said, no, you can't use CMOS, it'll get damaged. And I said, no, we're using light. It's designed to see photons, not designed to see what you do. It's designed to see these. It's not designed to see that. That smashes to bits. Well, they shut down CERN and put in CMOS, hardened CMOS. You know, and they knew about what I was doing. I showed them my stuff, and by the time we were done, they weren't arguing anymore. In the beginning, it was like, oh, you can't do this, you can't do that. You can't. I said, yes, we can. But we're starting with photons, not protons. And this is just stunning stuff. But here's the key. They're talking about entanglement. That's insanity. You saw these came through here, starting to the black and white, black and white. Bam. The black comes away, and it's dark matter. And the only reason we can see it is it's on top of the white. There's dark matter all over here. Dark matter all over here. But it only when it obstructs the white. And you're never going to see this because it's always inside the white. Once you hit atom stage, there's no black on the outside. That's why they say we can't find the dark matter. What's inside the white matter? But when you get down to this stage where there's nowhere else for it to go, you break one of those in half, and the black has to come away from the white. And that's what's happening here. And it's because of the restriction of the Venturi. And when I show you how this was done, you might want to have a diaper on. I'm sorry, my friends. I couldn't help myself, but it might be true. Now, I showed you the photons, right? There's photons right there. That's the green one. They're coming real fast. They come much faster than the red. And I prove everything I'm saying. Not one thing can I not prove. That was the green. I showed you the red. These are what the reds are like. Same thing, only it's just not going as fast. And again, proof of the pudding is right there. You see the green and the red? Now, I'm going to show you something that nobody knows about, sipping me and Rod. Now notice this. I said they spin this direction like this. They don't tumble like that. They spin in this direction and go forward, but they do go around in a circle while they're spinning in this direction. It's almost like the way the planet orbits the sun. They spin this on a pole and they spin around in a circle like this as they're going forward. Let me just try. This gets hard to explain to some people. They can't conceptualize it, but I'm going to try. You will never have a photon that's tipped sideways and spinning sideways like that. They will always be polarized to the Earth. And here's the proof of that. You see this green? How it's straight up and down to here? Even though it's going in that direction, you would think it would be spinning this way. It's spinning polarized to the Earth. I don't care what direction it goes in. So this is something to take into consideration. So if the light's going that way, I don't care. It's still spinning polarized to the Earth. Straight up and down, still spinning polarized to the Earth. Does that make a difference in the speed of it? I don't know. If you're going this way, it'll be affected by gravity, but it's still going to be spinning in the orientation straight up and down. As you can see, it's going this way, but it's still spinning in this way. Right? As the red does, they all do the same thing. They spin according to the polarity of the Earth. That's why it's straight up and down. Now, here's the key. Wait till you see this. This is the only time anybody's ever seen this, I guarantee you. Okay, two things to take away here. This is Fabien Boulay. And I believe he's over in France, and he worked with us years and years and years ago. And then, you know, everybody sort of goes away from it because there's nothing ever happens. However, here's two things to take away. This was Fabien's phone, or however he took these pictures, I don't know. But this is the green, same photons. Now, here's the green and here's the red. Now, here's why I say nobody in the entire world will ever see this except you and me. Or I've shown it before, but most people probably dismissed it. This green is coming through much faster than the red. Much faster. And the green is pushing the red out of the way. And you see how brilliant that is? Now, I'm going to home in on there. You saw this. And this just tells you that something's different between the Samsung, I think, and whatever phone Fabien had. But here's what he did capture, which was fabulous. You see the green? Look how brilliant that is. And it's gone into the blue range just as it comes through the Venturi. Blue just means it's increased in energy from green up to blue. Now, it seems to be going faster. I know it's spinning faster. And it's interrupting the red from its normal spin this way. It's made it roll into a barrel roll. I think this is the coolest thing I've ever seen. You see the red? It's spinning this way because its field, which is normally like this, is now getting pushed. Get out of the way. And it barrel rolls. I just freaked out when I saw that. Look at that. That's not supposed to ever happen. That is not supposed to happen. Isn't that something? Some of the red got thrown up in the top there too. They have different energies. Totally different energies. And I'm going to show you in some, like I say, some people have a hard time visualizing this. Let me show you what's going on here. Let's take a red photon. I showed you that light spins. Let me just be positive you understand this. This is light spinning. It's coming down this way. The light spins this way, but the particle itself spins this way. Even though it's going around in a circle, the particle in front of it is still spinning in this direction. Now, some of it will go that way, some of it will go this way, some of it will come way over here. They're all coming. There's a whole batch of these, not just one. As I showed you, the whole thing is surrounded, but you never see them. And the only time we saw them is because of the explosion. All right, the only time we saw them, we even know they're there, because the explosion backwards forces them to illuminate. And that's, anytime you have illumination, you have energy, increase in energy. This is a very big increase in energy, as far as I'm concerned. Now, so we have the red. All right, here's the red. It's going this way. And they are expanded out, the spin. Now, green would be down around here. And then you'd have a green ball on the end, because its concussive value would be into the green spectrum. Here it's spinning slowly, you see? We should have this back. This is backwards, but so the light's coming this way. It's spinning this way. You see it? It's spinning. You could see that as a wave, but it's actually a particle. All right. So way down here we're red. We get up into this spin, where it's pretty spinny. We're in the green, and when you get up here, you're in the blue, and I'm telling you, blue is a rocket ship. And here it is, the blue. You saw the red. Let's be sure I don't want you to miss anything. I don't want you to miss a thing. All right, there it is right there. There's the red. Let me turn this off. You see how wide apart they are? They're just hanging out there, having a nice time, taking life easy. Now the green says, I'm in a hurry, man. Get the hell out of my way. Pushes the red out of the way, and it just spins it tumbling down. Nobody's ever seen that. And that's something that blew my mind when I realized what was happening there. All right, so anyway, they normally spin on the axis to the Earth, up and down spin. Now, so that's that. Now, we see that the two particles are either black and red, or black and green, or black and blue, but here's the blue coming rocket ship fast. You don't even tell it's two particles here. Normally there's an up and a down particle in that particle, and you don't know here because it's going so fast. Now it's slowing down, slowing down, slowing. By the time you get out to here, you can see that there is actually two little whites in that one, which is the spinning particle, and moving this way as it spins. A very complicated little device. And again, here's what it looks like with the green. Same, the green and the red, no difference whatsoever. Zero difference. It's just that one's going much faster, and it spins the same thing, straight up and down according to the Earth. And these are the things, they can get big and they can get small. All right, this is going to be the best physics lesson you'll ever get in your life. That is the pulsed red laser. These are the particles of electrons that are in the gases that are in the air. Every field excites every other field. This is the acceleration. This is the explosion, literally subatomic nuclear explosion. Well, what happens right in here? What's going on in that white spot? Here it is right here, coming at us. What are these? They call them Higgs fields. Let's look into these Higgs fields, what's happening right in this area, because that's really cool. Really cool. And there's another thing that's even cooler than that. But you see these Higgs fields? This was a big deal back in 2012. Don Lincoln again. Oh, we found Higgs fields. Well, yeah. You know, I feel bad for Don Lincoln at FERMILAB because his whole life was invested in saying these things, and he realized he has to realize he wasn't correct. There's no possible way he could miss this. Now, this goes back to 2012. FERMILAB's significant contribution to understanding Higgs boson. This was in 2012 they discovered. They said, well, the Higgs boson was famously confirmed at CERN in 2012. FERMILAB collider played a crucial role in the years leading up to that discovery. Well, I don't know about that. It's such a simple thing. I have people finding Higgs fields using their thumb, and I am not kidding you. Okay, I don't mean to assault anybody. All I wanted was interaction, and they're talking about the Higgs boson, and this is in 2012. They discovered, oh yeah, we think we found a Higgs boson. And CERN and all of these people spending billions and billions and billions of our tax dollars. All I wanted to do was engage and show them that, yes, we feel we also have found the Higgs bosons. And here they are right here. Hold on. Here's some Higgs bosons on steroids. These are Higgs bosons. And that's because the white particles are now combining back with the black particles. And that is where you get your energy. In between here and here is energy. That's just like you could run basically anything off of that white. That white has no mass to it whatsoever until it hits the black particles, and then they just go spinning everywhere. You see that little white particle spewing out there and turning into that? I have looked at literally thousands of these images, and I fully understand what's going on here. All right, once again, these stunning, stunning shots. We're seeing the acceleration through the Venturi coming straight into our face is this shot. Right in here, you can't see anything. There's just nothing but this white stuff. When it hits the black particles, they just start spinning off on their own, which is called Higgs fields. Now, normally they spin in one direction. This is a killer. This is an absolute killer. You see that? You see that white particle? This is a Z-mind blue air. Normally these particles come out and they hit and they just go spinning however they spin. Right hand rule, they usually say. This one appears to be spinning left and gaining energy into itself. That's why it's glowing out there. It should be not glowing like that. In my opinion. I could be totally wrong about this, but I believe that sucker is gaining energy basically backwards. And these are displacing their energy outwards, which is what they're supposed to do. This one's grabbing and pulling stuff into it. To me, that's a backwards. Now let me show you what happened when this hit one of those. And I'm pretty sure this is what happened in this particular case. I can't say 100% certain it's the same incidence, but I believe it is. Because that one there, that's unusual. And I'll show you why I can say these statements. Here it comes backwards. Okay, once again, same with this same Galaxy phone. This goes back to the same time frame. Here's one of these Higgs fields. And there's another normal Higgs field. This is that white particle. All right, let me come open. Well, I'll leave it dark. You can see. You see that white particle right there? And it comes down to this one. And at that point, it starts to interact with this field. Now, this one is obviously going in that direction, spinning. And this one is going in this direction, spinning. They're going backwards. All right, so this one goes this way. and this normal one comes this way. Well, what is the end result of that interaction? This. And what is that? That, my friends, I don't know. Nobody has any idea what that is, because it's not, I don't know what it is. But I believe it's the white particle being torn away from this field. So this field, the white field part, is hitting this field, ripping it off, and just grabbing and spinning it like that, twisting it right off. So what would we see? If you looked at that right there, that's energy. And it's spinning in this direction. As this comes that way. This one is going that way. And it just grabs a hold of it and rips it right off. That's all I can see. That's what I'm taking from it. That's all I can see. You make what you can of it. That's what I see. That would be a new particle that is not anything that isn't, it's not a muon, it's not an electron. I don't know what it would be. Is it just the white? And can the white be completely separated from the others? And I think the white can be on its own at some points, in its own little ball nature. Normally you see it in the sprays, and they're just like the other parts I just showed you here before. They go into showers. All right, they're like this. This is showers. Now, are these any of these discrete little balls? And I think they are. I think you can find them discretely. But they normally are so energetic that they're pushing each other apart so hard that you just see sort of a fuzz. But for them to think that these particles, when they separate from the entangled particle, the black and the white, they separate, they come back to the same black one or same white one, that's really crazy. See, they know this happens. They've seen it happen. The muon, electron, neutrino, that's the black and the white balls, are glued together. And then when they get into the Cherenkov radiation, the black ball goes into what they call a sterile muon, like that black. The electron shower goes into the shower, just a fuzzy, hazy sort of glowing energy, which is a lot of energy. That's why it's just so glowy, because it's just really a lot of interaction of fields. Well, why are they interacting? In our case, they're interacting because of a Venturi. And I'm going to show you this in a second, because I got some guys right now that want to start investigating the Venturi. And I'm going to show you how it's constructed, how easy it is to make, and how, you might have to do some settings on phones or whatnot, because I can show you things that just are stunning, from just a regular cell phone and little lasers like this cheap stuff. Now, the Venturi forces the fields to crush, and the black particles, and the only time you will ever see them is if they obstruct the white. This is dark matter. It doesn't absorb, it doesn't emit, it doesn't reflect, but it will cover up white. The reason nobody's ever seen it cover up the white before is that nobody's ever done this with the Venturi. They've seen the black, but they don't realize it's dark matter. We see it and we understand it because it sits on top of the white, and only thing that you can't see is where the black balls are. Wherever the white is, there's no black. Now the black is sitting up, it's all over in here, just like it's sitting right on top of here. Black is everywhere. But the black ball that separates from here doesn't jump back to here. Entanglement is it's total nonsense. Honestly, it's insane, literally. All right. If you've ever done any physics at all, you've heard of the double slit experiment. And they took two slits in like a razor blade, flat as a pancake, two tiny little slits. And they see the light coming through, they think it's coming through like a wave. And it interferes with, they call it interference. And that's what creates these striped patterns like this. It's not. The light's spinning. They see just one thing here. They don't see that. They don't have the ability to see the kind of things we see. They just see these split apart like this. So they say it's flapping like waves on the water. No, it's not. This is, I believe this is a single slit. Now, when Rod first started, here's the first Venturi that he showed me. I said, how are you doing this? How did you create this acceleration? Which he didn't know what he did. I mean, he just sent me this, you know, and I freaked out. I said, how did you do this? And he said, I was doing a double slit experiment. And I said, can you show me the slit you use? And here's what he sent me. There was 3 nails. I'm not kidding you. This was done with 3 finishing nails. And I don't think it matters how many finishing nails you have or how many slits you have if they're real close to each other. You're going to get the same sort of effect. So I thought he only had 2. And I still think that that's all basically you need is 2 of them and come right through the middle and you just got it all. But 3 is good. There's no problem with that because it was extremely effective, as you can see. All of this was done with that and a little laser like this and a cell phone. Now, he told me that he used the selfie side, so I don't know. And he was taking them right down, right at the event. He's right in the face of it. Now, I wouldn't put your face in it, and I don't think he did either. But, I mean, it's just phenomenal work. Phenomenal. And coming out through the Venturi, this white stuff turns into Higgs fields. They're not Higgs fields until they concuss with the black. And that only happens at a certain distance out. Here they're separated, fission, complete electricity, basically. That's electricity. And here, back to fusion, and then they just go off on their way and become particles back in normal particles. Which, electricity is normal particles. Once it goes through the battery and through the thing, it just goes back into being normal particles. But you have no weight whatsoever in these white. There's 0 weight, 0, nothing. Again, your car weighs 4,000 pounds before you charge it up, and it still weighs 4,000 pounds after you charge it up. It doesn't matter charged, uncharged, in the middle, it doesn't make any difference. If you put 10 gallons of gas in your car, you just increase your car's weight 60 pounds, 60 pounds. Where did all the energy come from? Electricity. Why? It came from these particles. And the only way you can get those particles ripped away is either through a Venturi like we did, or through ripping them off in a generator, or to make gigantic explosions and then suck them off at the edges. We don't have to do that. We can squirt them. And I mean, when I say squirt, you want to see squirt? Here's a little squirt for you. Now, if you put a receiver right there, before it hit the Higgs fields, the black particles, you would just have all that white going into your battery, into your house, into your circuits, and you could carry it around in a lunchbox. All right, I showed you how simple this is. Back here is the pinch, which is this pinch right here. All right, so you're shooting down from your laser, your photons, they're all glued together. There's a strong nuclear force. Once they hit this Venturi, they can't go through. The black ones stay back here and slam the white ones through. The white ones squirt through as raw electrons. They have no mass, but they have all the energy. All the mass stays back here, basically, which is the black particles. And somehow there's a bunch of extra black ones laying around everywhere, and they reattach very quickly out here. Now, why can't we harvest that electricity right here? If we could get this Venturi working, which we can, I mean, there's no question, it's separating the white from the black. Is that electricity? I say yes. This is nothing is more simple than this. We have the laser here, shooting the particles here. The Venturi is keeping the particles separated. The black stays here, the white just slams through there. All right? If we put a receiver here, prior to where it could attach back to the black, because it's got a certain distance it's going to stay separated, and then it's just going to attach back, and you can see it's extremely abrupt. But if you're back here before it attaches, you send it down through a photodiode. Well, what is a photodiode? It's the same thing this works on. These work on photodiodes too. You hit with the light, which is a photon, it goes through the diode, through the gate of the diode, it can't get back. That's how photons work. I mean, photodiodes. I know this stuff very well. It goes through there, and we just force it into the battery. And if the battery is constructed correctly, it will have a place for these charged particles to go. Now, at a certain point, you fill up your battery, and it's just fully charged. But at another point, you use it all up, and you don't have any electricity in there, but it still weighs the same thing. And you can use out of the... Okay, remember, this was done by people all around the world, and it's based on Dipole Electron Flood Theory. Now, here is the ones from Rod. This is the electron showers coming out here, turning into Higgs fields after the explosion here. Well, what does CERN have to say about that? Well, they have the explosion creating the same fields, but they just have debris. We have light. We have this. When they came through like this. They have this. And they just have to dig through all this debris for years and years and years. And they're simulated. They can't really show you anything that's of any value. And again, this is Higgs from FERMILAB. That's their Higgs fields. It's just particles splashing everywhere. Because they're taking huge things, bam, and it just debris goes everywhere. It's like hitting two of these and everything goes flying. And here's what they say is their debris is this stuff right here. Proton, neutrons slammed together, all kinds of different debris. Well, we started here. We started there. So we didn't have to dig through any of that other stuff. Now, as I told you, some guy, my friend Renz, bonjour monsieur, he's over in France, he sent me this. He said, what do you think about this? And I said, interesting. Look at that. Look at this, and look at this. You see that? You see all those Higgs fields? These are Higgs fields. It's hitting some kind of a little dense water vapor area and creating showers of Higgs fields. Now, to me, the only way you can hit a Higgs field is to separate the black from the white. And when they come back together, they make the Higgs, as I showed you very clearly. So somehow, to me, there's a separation going on here and coming back here, simply from water vapor in the air. You see those colors? I'm sure you can see that if you look carefully. Now, this is Renz just pointing up in the sky with his cell phone. Now, it comes here, then it turns into blue, and then it turns into purple, which is basically what you got here and up to here. Now, I don't know if that's, I don't know. I really don't know. That looks pretty, it's got some energy. All right, you see it? That looks pretty energetic, which is up on that scale. And then you get to the blue is back here. And then you come back from there, you're way back down here in this red area, I guess. Now that's Renz. Now that's just pointing up in the sky. Look at this with his thumb. I'm not kidding you. Renz, you're amazing, my friend. Look. He put his thumb up like this to block out the sun. And the rays of the sun wrap right around his finger. Look at that. Red, blue, green, red, blue, green, red, blue, green. That's the rays of the sun. And you can see the Higgs coming right off of his fingertip. Isn't that something? And he says another one he sent me here. Hold on. There's another one. He's blocking out the sun to a degree, and it's the light that's hitting his finger is bouncing off. I don't know, maybe he's giving off some kind of energy. Renz, maybe you're an energetic person, I don't know, man. I have no idea, but it's he's just using a cell phone. Now, these guys knew what they're doing. Look at this. I think this was also from Renz. I'm not certain. Well, look at this. Look at that. Look at this thing here. I'm sure this is what creates this, or created that. And if you know how to look at these things, you see all those little lines in there? I don't think they're accidental. I think that's the spinning little particle spinning so fast that as soon as it hits the black stuff, it just splatters into a spinning disk, which is what I'm finding in all of our experiments. Now, are these little white particles actually white particles? I don't know. But I believe that's the main particle that turned that into a disk. And we can see that in our stuff too. You see how it's coming in like, pow! And I believe that one right there comes up like that and whacks right into here and starts to spin. You know, it's hard to really see them doing their job because they're just so much of an energetic ball. But every now and then you can see one that moves apart. And it looks to me like it's being absorbed right there as turning into a particle again. Because in the meantime, when it's white, it's nothing. It's just energy until it hits something. And I show that in that atomic bomb blast. The white hits the house, and the house just burns up, and then the black comes. Now, there's some black coming with the white. You can see there's black in there, but you can actually separate the white completely. However, some black, that's okay. That's all right. You filter that out through the photodiode or some filter device in there. Very simple. No big deal. You get that black out of there. It doesn't matter. When you're charging the battery, I'm sure you're flooding it with both things. And the dark matter just does not get absorbed. But that's Higgs on steroids. All right, now if you're interested in doing this, just go ahead and do it. I'm done doing experiments. Everything I've done, I presented the evidence, and it doesn't get taken. So if the more people we have doing this, the more we can create. Now, what I'm asking somebody to do is to take this, something like this, and these are pins. They're not just a little thing like that. They're like they're nails. And you're shining the light through this little slit in the nails. And because the nails are rounded, it forces the fields to compress, whereas normally they just splatter off of a flat thing, and you just get a little nibble going through. But when you have them coming down in a Venturi is a restriction. So all the fields are coming down, and when it comes through there, they just explode. And they know this. These are electron showers. They're electron showers. So the photons come in, the black can't get through, these shower through. We need to put a harvester here. And, you know, I was going to buy a bunch of stuff, little things on the internet. You can buy these cheap little solar panel receivers and stuff. All you have to show is that you're increasing the energy value from what you took to create the energy, so many watts, to what you could get back out of it as you harvest it on the other side. If we could prove that, it should go. If not, well, forget about it. And I have another guy, Rogran. He's working on magnifying the intensity of the light into a focus point, and then using water to. Boy, you should have seen the explosion of the water. I mean, the water didn't explode, but the light coming out of there was just unbelievable. And I think it might have something to do with the hydrogen in the water, having excess electrons and just spitting them out as possible energy. There's a lot of things we're looking at here. This to me is the most promising, but somebody's going to have to do it. I'm done doing the experiments and DNA tests and all the things I've done with all my research. Nobody pays attention. We need to have enough people presenting and saying, I did it. Well, Fabian did it. Renz did it. I've done it myself. Rod did it thousands of times. I have literally hundreds and hundreds of pictures of things that nobody would ever believe unless you actually saw the pictures. But if we can get harvesting that white stuff, which is the only thing you want, that's the only thing you want to make electricity. And that's the only thing you get to a certain point out to here. We can make it so that there is nothing but white. And at that point, you put it down through your photodiode. Once it's on that side, the case is closed. Now, it depends on the intensity of the energy that's slapping through there and how fast the pulse rates are going as to how much voltage, basically. Voltage is how much push. Amperage is how the flow, or the number of quantity. In other words, let's take a water hose. You got a gallon a minute coming through there. And if you just turn it off, it comes and a gallon a minute just runs out of there in a big. But if you take and focus that down with a Venturi, you go 30, 40, 50 feet. That's voltage. It's less amperage, but it's just doing that. That's all it is. This is basically nothing more than water, light. Now, so we need to harvest it there, and if we can get an over voltage, over amperage, more energy from here than we started with here, that's free energy. All right, I'm going to leave it at that. I love you all. Love to see this looked into, but once again, I've done it. It's done. You can see it's been done. This is not something that's impossible. It's something that's just not looked into for 10 years now. And this is not something that's not unknown. This is just killing me. FERMILAB, this is like 10 years ago. Well, they claim they found this in 2012, these Higgs bosons. We have them coming out of our ears, as I showed you. And we can squirt them out all day long. They just see them floating around here and there. So it's time to stop this nonsense. It really is. Again, this if you can't understand what I just showed you, I just can't imagine how they could have Don in charge down there. He says he's the gatekeeper. He's got me blocked. You want a phrase to find? Have a question? Yeah. Why won't you look at reality, Don? Anyway, I'm going to just leave it for that. It's very frustrating, my good friends, and we are spending literally by this time. This is 10 years. We got many billions of dollars wasted, and nothing back for it. I don't care if they wasted it, but if we could get back free energy, if we could get back something like this, you could walk around with a little bag full of electricity. Well, God bless you, Don, but that's not what's happening, my friends. It's not a good look. All right, I love you all, and again, we're paying for this. This is FERMILAB, this is CERN, these are Lawrence, Livermore, Oak Ridge. All of these things are just sucking up our money. I haven't seen much coming back out of them. They say, well, we're getting closer, we're going another. They're going to, these ice cube projects and deep underground neutrino things, they're there. They're all done 10 years ago. Somebody got to step up and speak. I've spoken up on I'm shut down. I'm literally shut down. I have over 200,000, I have over 208,000, I think, subscribers. And I get about, sometimes 2,000 hits, somewhere around there. I get about 1%. I don't think that's normal. And I have everybody telling me they're not getting notifications. I don't get them either. And I'm subscribed to my own channel just to see. I don't get them. And I have so much about space as well, because of the people we have that have no vested interest. You never get this from CERN or anything, because they say, oh, don't show them that stuff. This is the fields surrounding all the things that are in space. Light doesn't go through there and never get obstructed. That's insanity. The things that are around us, we have literally no idea where they are. If it's coming through this, it's going to be slowing down a lot more than if it's coming through out there. It's just field to field. And that's why it's glowing so much. And these are all dipoles, and this is the moon, and yikes, yikes, yikes is all I can say. You go and think about this. I think I've shown you some things. You see that blue around there? Why would that be there? Why is that blue around there? And what's this? And what's this? What the hell is going on there? All right, now this is just the moon. And you see all those fields back there? That field is not being given off by the moon. That's a different thing that's in the other side of the moon, which is a planet. Now, I got another one here. Look at this. What's going on there? I think I do know what's going on here. But this is a very, very strange. They're all dipoles, basically. But this is a strange dipole, which is a double magnetic field. You start to think about that. You tell me what you think's going on there. You see that field? And that field, they're two separate fields. They're not one field, but they're polarized, exactly identical, straight up the middle. And this is a very strange dipole. But it is a dipole, which there is nothing but dipoles. I got some other ones of well, here you go right here. I believe this is the Seven Sisters. That's just taken with a cell phone, with some kind of an app that said, I want you to look for separations in intensity of fields or something. Because that's what you got here. All right, this is more energetic than that, which bumps into this, which makes this one more energetic. You see them bumping out? That's how magnetic fields dissipate their energy. And out there, it's basically the end of the field strength, it looks like to me. But you see how they're black and white? This side is white dipoles, and this side is the black side dipoles. Very strange. This I have a hard time understanding. How come? I would have expected that. Well, they are dipoles in the center, actually, when you look real close. That looks like it. Yeah, I would say they're dipoles in the center, but why is that one so black over here? And I don't know. This is what I would expect to see as a dipole, only a little white and black. Depends on which thing, the way it's going through space, and everything is moving through space. We're on one of the arms of the galaxy, like this here. You see this? We're somewhere out here, and we are actually spinning around the sun, and the sun is going this way, dragging all those behind it, and we're all spinning behind it, going through this way. And sometimes we hit dense spot, sometimes not so dense. There's no telling what we're going to hit, I don't think. But I can tell you one thing, light doesn't go through there at the same speed. That is just insanity. And this Webb and Hubble constant, Hubble says that's it. Nope, no, that's why everything's pulling away from us, because we know that the whole universe is pulling away. That's why the light is going slower and slower. As I showed you, red is way out here slow. All right, so they say the light is coming here, but it's slowing down because everything's being pulled away. No, it's not. It's slowing down because it's just slowing down. It's not being dragged away, the expansion of the universe. That is just not that's just insane again. I'm sorry, that's just a fact. I don't know. There's some strange things going on that we need to start investigating. What's in front of our face? I'm not asking for anything special. This is what they show as gravity wave. They know that things are out there. See that? They're showing a black particle and they're showing a white particle. And they're all entangled, and this is out in the universe, and they're saying gravity waves are the same as magnetic fields. Well, yes, they are. Magnetic fields propagate around spinning particles, which are planets primarily. Okay, I think I mentioned, this is Dylan Carpenter. He's down in New Zealand, and he sent me a series of pictures, and I've just shown them to you now, and they show my dipoles and all the fields and all that. I don't know what kind of, he's just got a new cell phone, and that goes back probably 3-4 years, and I can see all the fields. It's just phenomenal what can be done with these CMOS cell phones. And they nobody ever realized they were capable of doing this. I studied them very carefully, and I realized, yes, absolutely, no question. If you look into that galaxy, it's exactly what it's designed for. This is exactly what it's designed for, to work in this range, not in the gigantic proton range. And that's why I was discussing this with University of Geneva when I went there for particle physics. I said, we can see these with the cell phones. And they said, no, you can't because you destroy the CMOS. And I said, no, we were using the tiny particles. I think I explained this. And they're hitting them with things like this. And of course it destroyed it. Well, they actually upgraded to use CMOS. All right, here it is right here. I just asked my good friend ChatGPT, why did the LHC, which is the Large Hadron Collider at CERN, upgrade to CMOS detectors? Well, my good friend Chat says the Large Hadron Collider upgraded to CMOS detectors for several reasons. Improved performance, yes. CMOS technology offers better performance in terms of speed and sensitivity. Crucial high-energy physics experiments where rapid data acquisition is necessary. Yeah, reduce power consumption. Yeah. CMOS sensors consume less power compared to traditional detector technologies. Yes. This is important for managing heat and energy efficiency in large experimental setups like the LHC. Not only that, they were interfering with the energy. So they call that the observer effect. So you say, oh, once you look at it, it changes it. No, it doesn't. Not looking at it doesn't change it. They put something in there to detect how much energy, or they put energy in to look at it, so it changes the energies that are there. So it does change the outcome. And Don Lincoln even says that. He says that in one of his articles here, that if you look at it, it changes. No, it doesn't. It's because you're changing it by and putting energy in or extracting energy out. All we do is look, and it bangs into our CMOS. We're just back here saying, hey, anybody out there? And it bang, 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 bang. It would have just gone by somewhere else, so it doesn't matter. We change nothing. So the integration of CMOS technology, greater integration of readout electronics, the same reducing complexity of the detector system. Very, very simple. Improving data processing speed. Now listen to this. This is why they said they couldn't do it. The radiation hardness. The upgrades include designs that are more resistant to radiation damage, which is essential given the high levels of radiation. Not in our stuff. We don't have high levels of radiation. We have light. When I say high levels of radiation, that means chunks like that. We don't have those. We have this. All right, so these high chunks of radiation present in LHC environment ensures the longevity and reliability of the detectors. And they're cost efficient and they work fabulously. They work just incredibly well, the CMOS. This is literally hysterical. The Hubble's law is also known as the Hubble-Lemaître law, is the observation in physical cosmology that galaxies are moving away from Earth at speeds proportional to their distance. That's insanity. They're slowing down because they're getting further and further away. They're getting slower and slower and slower. It's not that they're pulling away. It's that they're way out there, and by the time they get to us, it's very slow. So the ones in the middle are going a little faster because they're just not slowing down as much. There's not so much in the middle. This is insanity, literally insanity. And that's why they say there's the redshift. And here's what the redshift is. Hold on a second. All right, what happens with fields to field is called the Kashmir effect. When you bounce one field into another field, they don't compress, they expand. So it's like boom, 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 boom. And it gets right down to almost not even moving. It's called a microwave background. So the further the thing is away, the more it's slowed down. So the more redshift it is. It's just because of the distance. And they say it's proportional to the distance. Yes. It's pretty obvious. If it came from here or from a bright object, it's bzzz. But if it came from way back here, it's bzzz. It just stops in the middle of nowhere land, unless it hits something. That's the nature of light. It's not red shifting. It's really unbelievable that they believe that. And they think that this happens from every angle on Earth. So in other words, we're the center of the universe, because we're expanding in every direction away from the Earth. So obviously we have to be the center of the universe if everything's pulling away from us because of expansion. It's not a well thought out plan, my friends. See, this just came out minutes ago. This is from NASA. That's unbelievable. Webb telescope encounter with a time-bending supernova rewriting cosmic rules. And then they come down and show all this stuff, these little graphic things. And then they say the discovery of this SN Hope, a distant supernova observed through gravitational lensing, has allowed researchers to precisely measure the Hubble constant. How does the Hubble constant? There is no Hubble constant. These constants, these laws of speed of light can't change. That is where we run into absolute nonsense. And it's just totally wasted money, all these things. We can see out there. We see them, yeah, they're out there, but we don't know how far they are because they're coming through other things that are slowing them down. So they get stretched and stretched and stretched. Not they're pulling away, so they're stretched. They're just getting slower and slower and slower, and then all of a sudden they'll just hang around out there. As my little doodle here shows, this is what happens on the sun or any luminous body. They're scrubbing through space just like everything is, and right at the outside edge here, it's literally millions of degrees, only 10,000 on the sun, and that's why it's so hot out here, because it's scrubbing. Same thing with us. We're 2,000, almost 3,000 degrees out here. And as we expand by burning more and more stuff, it gets bigger and bigger, and it gets hotter and hotter out there, which is why we're having so much turbulence and global warming and flooding and all that. It's going to get much, 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 much worse as we continue to expand the envelope. But here is the scrub zone. It's like 3,000 degrees out there. They can't explain that. It's say around 100-ish on the surface at 3,000. No explanation. 10,000 on the surface, millions out here, no explanation. They're going to spend billions of dollars to try to figure that out. Global warming is caused by this friction out here. And because it goes from about 3,000 degrees down to about 100 and something below zero. And then it comes back up again. It's a dipole, hot, cold, hot, cold, hot, cold. And the Earth is what eventually absorbs all of that. Now, the moon sends out particles, but they bounce. The moon gets hit, and it's a reflectivity. It's not an emitter, I don't believe. All right, so there's no like emission from that. It's just not scrubbing hard enough to give off any radiation that's of consequence, to my mind. I'm not certain. But we certainly have a very serious amount of scrubbing going on. And it's because of all these particles that are in the sky. Everywhere. They're everywhere. And they say the whole universe is pulling away from us in every different direction. That would make us the center of the universe. And they say that's what's happening. That's why light is pulling this way, like opening up and coming towards us, red shifting. No, I say it's out here spinning fast, and it boom, 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 boom. That's what the redshift is. It's light slowing down. How much does it slow down? Well, if it comes through this, it's slowing down quite a bit. If it comes through that, not so much. We know these things exist from all their fancy little telescopes and so forth. And this is the University of Arizona. I had some issues with that. They tout their research, but I haven't had a single one of them talk to me about anything that I've tried to engage with the things that they say. Right? Department of Astronomy, University of Arizona, and so forth. Now, I'd like to speak to some people out there, because they have, I believe, some of the bits and pieces of Comet Bennu, and I have been commenting on that. I know exactly what Comet Bennu is, and I need to speak to somebody about that. Whether or not they'll engage, so far, no. All right, but anyway, I can't go on this forever, but as I showed you, things are not as they say. And this rewriting the cosmic rules, bending from supernovas, before they can do anything, before they can understand anything whatsoever, they have to understand Dipole Electron Flood Theory. Anatomy of the proton is the dark center with all a cloud of electrons around it, not just one or two or three. And these are the only two particles as the dipoles. They make up everything. Each one of these is a little tiny bar magnet, just like that. And at a certain number of them, they create matter. That's all there are, is these two, and they can come in different energy levels, which you call colors. And each one of them is an electron, has the black part. They never know about the black part. They always say, oh, a glowy electron, it sparks, it jumps, it's static electricity, lightning, electricity. Yes, but it comes with the black. Now, if you can separate the black from the white, which is what we did, then you got raw electricity. This together is basically heat. It's a gluon. Now, if you take two of these back to back, just like two little bar magnets, you get a photon. As I showed you, the photons, I showed you all of this stuff. There's nothing I haven't shown. And there's going to be some changes. Chemistry, space and time, the redshift. I don't think there's no way you can miss this. Fission, fusion, raw energy, possible harvest. It's just exactly what they say. Muon neutrinos, the black ball, electron showers, the white showers. I don't think that I've missed anything that, unless you can find something that you can comment on. There's no question things are coming through space. They're going to have to slow down. No question whatsoever. Zero. If a physicist says to you that there's no way that anything can slow down, the only reason to say that is because Einstein said it. That's why. It absolutely slows down, just like this light is slowing down. And it's spinning to the right, drifting to the left. That's one shot of the whole thing at once. And we're seeing all of those particles of the blue. And it's spinning like crazy. And the particle is on one, as it moves around, the particle moves around. So we can actually see it moving around in circles. And I can show in many places about it moving around in circles. You saw this. I had a whole batch of other ones here, some really cool shots. I get so much stuff that it gets boring after a while, so I'm just going to shut it down now. But it's time to look at this carefully. And I think if anybody wants to try this, it's very simple to do. But there is, like I say, I forget what I told you, but there's modes. They put them into these special modes where you can see these particles better. And this seems to have it. Now don't forget, my experiments with Rod Warren go back to 2012 with the release of the Samsung Galaxy S3. I'll show you in a moment. I have been doing this stuff for 50 years. I mean, I have more on, everything, chemistry, physics. All you have to really understand is that Dipole Electron Flood Theory, I predicted back then, and I said the transfer of energy is from light to atomic vapor. That's the black and white particles. The black one and the white one. And the white one can absorb energy and move away and become a big field. Now, there's no way. At this time, I didn't know a lot about this. But I did know it had to be dipoles. And I came down saying, if this is therefore Rutherford's atom was wrong. Everything was based on his atom. I said, it's not right. And then I went through the spectrum and some other things about Rutherford's atom. Electrons can exist at any distance. Anyway, that is, and there only are two types of intermolecular forces, and they are dipoles. Dipoles. There's polar and nonpolar dipoles. But dipoles means they're polar in nature, but when you add them together in certain quantities and at certain bond angles, you end up with certain what they call dipole moments. In other words, let's take this. Hold on, let me put this together. Hold on. All right, here's Don Lincoln again. This is the observer effect he's talking about. So he's saying if you magnify an extended particle, that's the black one, it will look bigger and bigger as you magnify it. So it's like a ball like this. And if you get magnified closer and closer, it just looks bigger and bigger, that's all. Now, a point-like particle, which is these, will not change in size. So he's saying that little dot in the center is the point-like particle. It doesn't change in size. This one just gets bigger and bigger. But this one doesn't. However, the field, this says a point-like particle will not change in size, but the more closely you look at it, the stronger the field surrounding it becomes. The more closely you look at it, what does that mean? If I go in really close like this and I look at it with my eyeball, that gets bigger? No. No, absolutely not. You are pushing a field into that. They're taking pictures of that with energy. They're sending energy in and it's bouncing back. So it fluffs up. It's push to shove. Simple as that. I mean, it's just so simple. It's unbelievable. And and then he talks about the quantum foam, and I agree with this. Empty space isn't empty. I showed you that. There's zero possibility that particles in space are traveling through there and never slow down. It's just literally, it's just impossible for anybody to believe that. Literally impossible. This is what space is filled with. Not only that, these are fields. Fields push against other fields to slow things down. And they're going to slow down. I don't know how far this stuff is away. Nobody does. But they keep saying, oh, now we know this, now we know that. No, you don't. They have no idea where we are. Zero. If we're back here, it's different than being out here in the darkness. It's a whole different situation. Light cannot go the same speed through the universe. And I can show it speeds up and slows down. Einstein was totally wrong. Completely wrong. If that's not light speeding up, you explain that to me, Lucy, because that is light speeding up. And on top of that, that is light slowing down, monsieur. And if you can't see that, I'd like you to explain that one to me. And this, monsieur, is light dividing and reattaching over there. And it is identical to the muon and electron neutrino as you create Cherenkov radiation, where the muon goes on its own, the electron showers do that. And the muon, I claim, is gravity and wants that white particle to come down to it. That's why all light hits the Earth. It's because it has a white particle. All right, the black particle just keeps accumulating. So the Earth is ground, and then the white always wants to attach to the black. Everything has to be grounded. Electricity will flow, but it has to get to ground. And you can have a floating ground, or you can have earth ground. This is just same thing. Different way, same thing. Okay, mes amis, I think I have shown you enough to make my point. Now, the other point I want to make is that if you are currently taking like history or geology or physics, anthropology, archaeology, anything, anything to do with space, anything to do with light research, any of that stuff, chemistry, biology, even health, even spirituality and eternity. If you're looking into any of that stuff, you better look here, because you're looking in the wrong place if you're going to academia. They are going to support their fact that there is no God. None of that stuff exists. It's all nonsense. You believe Roger, you're a nutcase. And that's the realm you will be in for the rest of your eternity, I believe. There's something else going on here. You're not going to just die and that's the end of you. Not in my world. I could be wrong, but not from what I've studied. I think I have a pretty good handle on the fact that something's coming up. Now, what it is and what you do to get to where you're going to go, that's a whole other issue. We need to deal with that and talk about it. And if you don't want to talk about it, good for you. That's what I say, good for you. So, I guess I'm going to call it quits for today. But don't forget now, virtually everything in mainstream needs to at least be reevaluated, and we can discuss it. I could be wrong, but I'm showing evidence to support the things I say. These are not just, oh, there must have been 500 million years ago this happened, and 600 million, and 10 billion zillion, and light never slows down, and all of these things. It's just not true. They're just a Hubble constant. It's just ridiculous expansion of the universe. No, light is slowing down. The further the things are, the slower it is. It's just obvious. And even global warming, scrubbing through the universe. We're scrubbing. That's what's creating the heat. And turmoil. Oh, terrible, terrible turmoil. All right, so anyway, I'm going to just leave it at that. But, you know, go through this a few times if you didn't pick up on it, because this is reality. And if you're going to be going to school for reality, you better come to this school, Mudfossil University, because that's the only place you're going to find it right now. I'm going to tell you that's just an absolute fact. I love you all.